2, 1, start. Okay, so this is just a quick demonstration of the audio-visual interface for the solar car project that I made. So the main focus is on the audio, but I've made this visual demonstration just to help demonstrate the ideas. Anyway, so I mapped a bunch of parameters that are supposed to allow the driver to interpret information peripherally and to focus more on the road rather than focusing on reading visual interfaces. Anyway, of the parameters that I mapped, the first one that I'll demo is, sorry, that's the bass tone, or the idle tone. The first one that I'll demo is the speed change, which is just pitch. This is a common relationship in mechanical devices anyway, so it's intuitive anyway. So there's a 2-octave range between idle speed and maximum speed. That's all there is to it. The second parameter that I changed is the power, so the amount of power that you're sending to the electric motor. This is represented via wave shaping the sub-oscillator from a sine wave to a square wave, which you'll hear now at low speed. You can see it's also represented by the green bar. And going up to high speed. And back down. And the speed back down. The third parameter that I mapped is a basically available power from the battery. It's represented by a filter sweep on the sub-oscillator, which you can hear here. It's a rapid sweep. That chattering sound, you can also see it in the spectral graph where the frequencies are being cut out. That's just representing it like a spluttering motor, I guess. So again, this is another attempt at an intuitive mapping that's mimicking mechanical or traditional mechanical sounds. And yeah, the final parameter that I mapped, second last parameter that I mapped is energy in. So the energy being received from the solar cells. This doesn't have a traditional noise. Solar cells don't make any noise. So I explored a few options, but the one that I found most intuitive in testing was a sci-fi kind of noise, because, well, anyway, you'll hear. So this is like a common noise in I guess, sci-fi movies to represent something being highly charged or high power. And here it is at full speed. So it goes up into an even higher frequency, like an overtone, and at high power. And all of them back down. And the final parameter is an energy in versus energy out. So it's a relationship rather than just a straight number, and it's done via a slight detune of one of the oscillators to put them out of sync. Which you can hear here. This is the most subtle of all of them, because often you'll want to be in this situation, so it should be, yeah. But you can also see on the power bar, it also changes the color of the power bar. So at green, it represents a net energy gain. So the solar cells are providing more energy than the power being output. So you're charging the battery. And as it shifts further and further to red, you're going further and further into a net energy loss. So you're using more energy than received from the power cells. And everything at full sounds like this. Anyway, those will obviously be modified so that there's less noise would be modified so that they can sync back into background noise. It's just, a bit complicated. Anyway, that's the demo done. Thanks for watching, and yeah.